What now? Oh, there he goes. Fine. Hey, it's just Cliff Click with Coffee Compiler Club. Here today, hopefully talk about compilers and language runtimes. And some people had suggestions they pulled out, which is good because I don't have any set agenda. And I will be busy doing other things on and off. So I'm really hoping that I get somebody else to start with. And you've all been recording and show up on YouTube in an hour or two, or actually much later today, because today I'll be busy. Well, and there's Levo one more time, because I have him on his phone and on his. Excellent. All right, what was going on in Discord this morning that we should do with an initial topic here?
Well, I have an update. It wasn't on Discord, but if we want to start there.
Yeah, fire away. Simon was on at some point, but he's not on now, and people were talking about
that he couldn't make it to the actual meeting.
Okay. Some conversation about array syntax versus function call syntax.
Yeah.
All right. Yeah, well, fire, Darrick.
All right. So, well, I've got my programs running on our hardware, and it works. And I did a demo to our board the other day, and they were thrilled because
that's a big
showing about 100x developer productivity improvement versus our previous technique of not having a custom language. So yeah, so that's those are numbers people on a board can seem to be
relate to.
Yeah.
yeah. And, excellent.
So newfound enthusiasm in the company for this weird solo project that I've been doing for the past year. So yeah, but now I'm trying to figure out, okay, how do I actually link with LLVM code? I didn't actually get that working last week. I was busy doing some other stuff, and I don't know, finding little weird annoying bugs in my register allocator and stuff like that. But it's actually, yeah, it's actually working and producing reasonably good code running on our PE array. So pretty happy.
Awesome.
Yeah.
I'm going to put that in the win really category for Sea of Nodes.
What's that?
I'm going to put that in the win category for Sea of Nodes.
Yeah, I think it belongs there because, yeah, like the parts that work best are those, and I keep on being able to add like new optimizations or new pieces, and they just sort of slot in without really having to change anything else, which is awfully nice.
Excellent. You can't see my thumbs up. I'm chugging my slime shake.
Yeah.
It's just so nasty. Holy.
So I have a question. Is the compiler you made open source, or like how is it going to be released?
It's not open source yet. I'm hoping I'll be able to convince them to open source it, but right now it's proprietary. Although a lot of the code that I used in the backing code like is open source. So I took a kind of, you know, overall it's definitely a Sea of Nodes compiler. It's got the lattice typing system, and the structure is the Sea of Nodes structure. But some of the details of how I approach it are pretty different. Like instead of sort of pointer-based graph of nodes, I actually have a like a labeled property graph that's more of a formal graph, like in-memory graph database that I use for doing the compiling, which makes it a bit slower because it doesn't have the memory locality and stuff. And there's more objects, and I have things like edge objects that I have to traverse to before I get to the next node. But I also am able to, for instance, add any other kind of edges to the graph, and I can have all sorts of other information tied in, and the whole graph is immutable, so I can record the whole process as the compiler runs and grab like
the graph's immutable.
If I want to see what happened at people number 852, I can literally grab a copy of that graph and grab the copy before. I can diff them, and I can actually rerun the people stepping through it, and it all works. So that's what's that?
That's pretty nice.
It's pretty handy. It certainly speeds up debugging. So every time I get a hairy compiler bug, I first get really nervous, so that then I usually hour or two later, I've got it figured out. So
there you go.
Yeah.
Yeah, that was my general experience as well.
Yeah, but those tools, like the graph that I use and the whole pattern matching approach that I use for defining the peephole rules, that's all open source. So, and I did that presentation. I think I posted a long time ago, this presentation that I did in some Clojure meetup group on the on pattern matching thing. And I've made it a lot better, actually. I spent a few weeks in the past month adding a bunch of cool features to the pattern matcher too.
I only ever did direct inline, like C++ code for patterns. You get one virtual call on the base of the pattern, and then after that it was if, then else, if, then else.
Yeah. Well, that's got to be a lot faster, because every node right now, like, I mean, there's lots of obvious optimizations I could do. For instance, categorize my patterns by the type of node that they apply to, and at least only.
Okay.
But right now, every pattern starts with check the type of the node.
Yeah, right. So you're running every pattern on every node.
Every pattern on every node.
There's some quick cutouts for a lot of them.
Yeah. So the cutouts are quick, but yeah, it's the compile performance is fine, even for interactively developing. Even as the programs are getting bigger, it's not a big deal.
Yeah.
So yeah.
You get speed it up if and when it's necessary.
Exactly. Yeah. So on-demand optimization is my
right. I can imagine you're going to be doing optimizations for a while instead. There'd be cool, faster code gen things to do, or better code gen things to do.
Yeah, exactly. So to get real world code running, I needed to cater to the compiler a tiny bit, but not too much actually. Like code still looks pretty straightforward. So.
Cool.
Yeah. So that's my bit.
So anyone else want to say something? Like people on Hacker News talking about array assignment using function call syntax.
Yeah, so like there were 3 overlapping topics. So one question was like, what was the point of submitting your programming language to like Hacker News or Reddit or so on? So number 2,
abuse of the masses.
Yes. So number 2 was like there was like the different syntax questions. So like, I mean, I don't know, maybe it's worthwhile to use Hacker News to design syntax, maybe it's not. And then
all right.
And then number 3 was Levo's language, Bolin. And the question was like, why it hasn't been doing well on Hacker News and Reddit. And
well, I haven't asked that, and I don't think it's not doing well, but you did ask that, and I'm not sure what answer would satisfy you.
Well, yeah. Here's a different take.
No. You let me go back in the scroll. Like, I'm pretty sure you specifically said like my language did not get many upvotes on Reddit. Let me look at this.
Let me throw out here that
my experience on Reddit.
All right,
no
Alan,
one comments and it falls off. That's specifically what you said.
All right.
Okay.
I think a better way to think about this is, why do you care how many Reddit votes you get?
This ChatGPT told him to.
Yes, exactly.
No. It's because the more upvotes you get, the more useful comments you get from other people, right?
What?
Like, think about it.
Not
What?
really.
I'm sorry, what is the correlation between upvotes and useful comments?
Yes. So like, I mean,
even now you are grinning
wait. I actually think he has a point here. So hear him out. Alan's
like,
onto something.
So there's all these people and they're browsing Reddit, right? And like, most of them, they never go past the first page, right? So like, some weird number of them browse the new page instead of like the front page because they
Right.
like seeing, less common results, right? And so they see your post and they're like, oh, this is an interesting programming language, why don't I click through it, right? And so then they click through it and they see like, oh, it's Boolean, it has automatic memory management. It's just like V. And so they look at the comments, and the comments are like, oh yeah, this is just like V. It's just a clone that's like not very useful. And
I
so then they're
think you're
like,
the
oh,
only one that said it's like V, and I do get a lot of DMs, not messages, but DMs.
You have to assume that
comments.
Alan's going to be on there writing that comment as soon as he sees your post. So that's the one comment you'll have guaranteed.
so okay. And so they don't upvote it. And so it never gets to the front page where like all of the, normal users hang out, right?
So
And
normal Reddit users about languages, or just
Yeah,
normal
yeah,
Reddit
like the
users?
normal
So I
people
just
who
want to
browse
be
the
clear.
program, like,
That's not normal. It's normal on Reddit, which is very abnormal.
That's what-
no, Reddit is used by like millions of users. It's completely normal to use Reddit. It's like editing Wikipedia. I edit Wikipedia all the time. It's completely normal.
Fine.
There's
sorry.
people who browse Reddit and people who comment on Reddit.
Okay.
And the people who value Reddit upvotes.
Yes. Okay. Fine.
No,
But
but
like,
Alan's point is right. If you get buried initially, then no one ever sees it. So there is actually a benefit, even though it may seem silly at first. There is a benefit to getting an initial surge. So here comes my things I shouldn't say in public. So years ago, I was trying to get something for people to look at. And every time I'd post something, and I think this was Reddit, it doesn't matter what it was, but it would get an initial 2 or 3 downvotes from the same downvote brigade as would show up on every, on everything that, wasn't their favorite, whatever. And so what I found was all I needed to do was contact this guy in Russia who owned 12 million accounts. And for a small fee in Bitcoin, he would sell upvotes. I think it was Reddit, it doesn't matter. But basically all you had to do was like get 10 upvotes, right? And then it would like take off. So there was a function where basically you spot yourself -3 and then it goes nowhere. Or you give yourself 5 or 10 upvotes and it goes to the moon, right? So it's kind of what Alan's talking about. So I actually have I've actually tested this theory, and Alan is, in this case, absolutely right.
So you have a business relationship with a Russian who
So it
sells
turns
upvotes
out
on
the
Reddit?
only time I have ever used Bitcoin is to pay Russian hackers to use their fake accounts on whatever. Yeah.
Holy moly.
That is why I'm invested in Bitcoin. Not joking.
No, that's fair. That's
And
fair.
if you had just kept those Bitcoin, you could have like bought a house with it by now.
I think I still have them. I just haven't had to bribe any Russians lately. So
okay.
I don't know, that's bribing. That just sounds like a straight up business transaction.
yes, it is.
But I think Russians prefer you to consider it a bribe. That way they feel better about the transaction.
So I was scrolling up farther in the chat, and so like,
And Alan, I just want to be clear. I'm never going to agree with you again. So cherish this moment.
no, someone disagrees with me. What will I do? Anyways,
Bitcoin,
the topic that brought us onto Reddit was object-oriented programming. And the question was like, how do I make my language support object-oriented programming without someone on Reddit calling me out and saying, oh, actually, I have a different definition of object-oriented programming, and your language doesn't support mine. And
You
so
should
I was
support
like, oh,
all definitions of object-oriented programming all at once.
right. And so like, I was like, that was like the perfect idea, is you just support them all. And who was it? It was Jamie Willis. Is Jamie Willis on here now? I don't know.
He's not on right now, I don't think.
Okay.
Yeah.
But he was like, nobody's going to say your language is rubbish. and I disagree. I don't think that's true.
Matt's
Yeah.
posting that you can't satisfy all the depths of OOP.
Levo will definitely say that your language is rubbish, as will Simon.
Okay.
I got mixed feelings about a lot of paradigms, but I like object-oriented or object-oriented programming every once in a while. I support it.
Yeah, like nobody wants to say that they don't support object-oriented programming. Like that's kind of the.
I thought you browsed Reddit.
Yeah, I was gonna say there's definitely that OCaml crowd out there of college students who are like, you know, I want to work at Jane Street and object orientation sucks.
Hmm.
I
Oh,
thought
that's
Jane
cool.
Street was going to move away from OCaml.
I don't know.
I heard
I
something
think
about.
I thought that was the joke I made up.
Oh, that was probably the joke you made. Yeah, that's probably true. So that I'm far enough out of touch with OCaml and Jane Street that I couldn't tell it a joke or not.
OCaml's actually pretty cool. So, but don't tell anyone I said that.
Okay.
Mhm.
All right. Something else before I lose myself and have to run off.
So,
have-
well, what's object orientation?
There's a theory, and then there's just like what the hell is useful.
I mean, do you want me to get into this? You know, I wrote like this whole like, you know, web page on it. And
So
like,
you have a definition of object-oriented programming. And what's Alan's object-oriented programming?
well, it's not mine, it's ChatGPT's.
You
So-
gotta start saying Jippity.
Are you taking?
ChatGPT.
Are you taking? Yeah, ChatGPT. Are you taking ownership of this definition, or are you just going to hand us, you know, crap from
So-
ChatGPT?
Okay, so ChatGPT, like it's random, right? Like you ask it the same question, it'll give you a different answer if you ask it to regenerate the results. So what I did is I asked it 10 times what object-oriented programming was. And it gave me 10 different definitions. And then I took like the common parts of the definitions. Okay,
Are you claiming there's a statistical process involved here?
yes, I did indeed collect 10 definitions. So, I mean,
So what
You
you're
know,
saying is
you said
ChatGPT is using you as a learning node?
Yes.
no, like ChatGPT, it already
This seems somehow
summarized the
inefficient.
internet as like one blob of data. So like I'm just querying the data to get different, aspects.
Alan, you're teaching ChatGPT. This is like so wrong on so many fronts. If you sit there and probe it with questions over and over and over again with mild variations, how is that not teaching ChatGPT? It must be learning from your questions.
I mean, I'm like, what? There are millions of ChatGPT users. I don't think it's like I mean, it's learning from the data, but like, how much is it learning from me specifically? I don't.
I'm giving you shit, sir, and you're just like eating it up.
Yeah, this is-
I would
and-
say the problems start much
definition.
earlier. They start with the sentence, I asked ChatGPT.
I did successfully ask ChatGPT to write a poem to my daughter's like favorite name is Llama Queen. So I write a poem to the Llama Queen, and it did a great job writing a poem to the Llama Queen. Not exactly the same kind of genre as define OOP, but
Yeah, I think there are generally three models of programming left at this point. You have kind of if you think about it as the XY axis, at 0, 0, you have just normal procedural development, imperative procedural, call it COBOL or Fortran or whatever. And then going up one axis, you have basically a centrism around functions, and in the other direction you have a centrism around data. So it's either data oriented, which we call object oriented for lack of a better term, where we collect the functions around the data, or it's function oriented where and it's very hard to combine the two. I mean, this is the whole what's the problem? Not the whole
not the
thing,
expression problem.
the expression problem. Yeah. So I mean, the expression problem is basically, well, wouldn't it be great to have both? And
Yeah.
of course, lots of smart people have failed to do so. So anyway,
No,
but I
it's
mean,
simple.
what
It's
what
called
else is
Julia
there?
multi-methods. Answer to the expression problem is Julia multi-methods. There's no need for anything else.
And see, now you're being sarcastic because no one who's actually used multi-methods in Julia would agree with a straight face.
But it solves the expression problem. We were reading this recent paper. It was like, and it said explicitly that Julia multi-methods solve the expression
What's the
problem.
statistical difference between reading a random paper and asking ChatGPT?
Ooh,
Oh, well, ChatGPT only works on like knowledgeable results or like common things like oop.
It doesn't
Whereas,
read all
like,
the papers?
For the
Thought it-
specific concept like the expression problem, it generally won't give you anything useful. It'll just hallucinate like random things that aren't related.
All right, and you're just like lining yourself up here, sir, for the next, you are a variation of ChatGPT who reads all these papers and hallucinates the answers out. And I'm just like, oh, don't go there. But I did, so I'm sorry. I apologize now.
Wait, you're calling me ChatGPT? Look at this. You see, I'm a video. I'm like a human person. How can you call me ChatGPT?
we can't verify that though.
You may be controlled by a ChatGPT inside.
Yeah, a lot more folks are being controlled by that than never mind. Stop while we're getting into the behinder place here.
They do generate voices pretty well now.
Oh God.
Says the guy with no video.
Yes.
Oh, we have degraded down into some kind of rat hole.
So I think Levo wanted to give us an update. He had an update he was going to share.
I don't remember seeing anything about that.
I
I
wanted to
did
hear-
want to ask Simon about some syntax question, but he's not here.
Or
Well, that
it-
was the Hacker News on.
or maybe it was Yorick. Did you have an update, Yorick?
I mean, I have plenty of updates, but I didn't specifically announce any. Like,
I thought someone had started to, but say, since you
I mean,
don't, go
I
ahead.
can give an update, so we're not
Yeah.
in silence. Let me see. What did I do for the last couple of weeks? Yeah, I think the first one I got my FFI working again. When my language was interpreted, it used libFFI. But since switching to a native compiler, I removed that because libFFI in that case doesn't really make much sense. I guess unless you like have a plugin system of some sort, but I think even then you can just use DL open. So I, excuse me, I spent some time implementing a proper FFI. Took probably a couple of weeks because you end up with like interesting challenges in the sense that I think I mentioned it last week. You get these calling convention differences where
Struct return.
LVM claims they follow the C calling convention, but they don't quite do that. And for example, I initially, when I had it implemented, I did not support variadic C functions because I thought, yeah, they're not very common and they're kind of not, not very
Other than printf.
safe. But then I started trying to implement a SQLite client and a curl library, and both make use of variadic functions, but for really stupid reasons. They have a curl has a function, a curl easy set opt, whatever it was called.
Yeah.
But it always takes 3 arguments. It's just I think the type of the last one that differs. So instead of having, curl set opt string, set opt int, whatever, they decided let's use variadic functions. And they're the things I think on x86, if you pass below a certain number of arguments, the call-in convention, I believe, for variadic arguments is the same as a normal function. So in other words, if you take, say, printf and you give it 3 arguments, say to the format string and some value to format, You can call that just using normal function calls, and it will work sort of by coincidence. But then once you pass too many arguments, it starts to break down. So I had to support that, which in the end was actually very easy. Like LVM supports it very easily. Just, you know, had to change my type checker to support this. And you get other things like linking libraries, specifically dynamic versus static linking. I decided to go with dynamic linking by default, simply because only for C libraries. So my own code is still statically linked. But the reason for this is that, at least on Linux, a lot of distributions, when you install the library of something, they will only ship shared libraries. For static libraries, you typically have to install an extra package. So if you want to use zlib, for example, you do, you know, apt-get whatever, install zlib dev, you know, whatever it's called, and you get the shared libraries. If you want the static ones, you have to do zlib static or something like that. But not all distributions do that. Arch Linux, for example, they with LVM 15, they stopped shipping static libraries of LVM. So they only have dynamic libraries, so you can't, unless you install LVM yourself, you can't statically link against the system LVM. Yeah, my throat's a bit dry. So I went with dynamic by default, static as an option. But then you get these things where like, oh, on Clang and GCC, there's a flag where you can say all the up and coming arguments, they are library names that you should statically link. That way you don't have to give the full path to the libraries. But on macOS, there's no such option. And in fact, on GCC, there's actually two ways of doing it. And one is kind of GCC specific. The other one also, but is actually implemented more widely, I believe. So the whole process of trying to find static libraries and link against them without re-implementing all that logic, like, hey, on this operating system, the libraries are here, but on the other one, it's over there. Like in the end, the final solution was fairly straightforward, but getting there was quite annoying. And I think in the end, I basically said, oh, static linking on macOS is not supported because there is no option where you can say, hey, here's a list of library names.
Yeah, I heard that
Pick
too.
the static one. And there, another difference, like if I remember correctly, on Linux, if you do, you know, the usual -L option to link a library, it will always pick dynamic. On macOS, it will pick dynamic if it's available, and I think otherwise it falls back to static or one of the other way around. But you can't force one of them. So if your compiler has an option, you know, --static, for example, on macOS, you have to implement the logic of finding where those libraries are and specify the full file path as a command line argument. Whereas on Linux, I think it's like -W static begin or something. Then you list just -L, A, B, C, etc., and it will statically link it and do all the finding for you. So on macOS, I ended up saying, oh, if you have the static flag, it will print a warning saying, hey, static link is not supported on macOS, we're dynamic linking instead. So that's the first sort of big thing. The other thing I started working on is type specialization, or the monomorphization. Quite a big, quite a mouthful.
That's the right one.
But it's very slowly sort of ongoing because it's at this stage where I sort of roughly know what to do and how to do it, but I haven't quite convinced myself yet. So I spend a lot of time just sort of staring at my screen, taking notes.
Yeah, you had asked about the whether there was any shortcut or if you actually had to expand the non-monomorphized type for each specialization.
Yeah, it wasn't, I don't know if shortcut was the right term, but
You said something like certainly there has to be a better way to do it.
So
than this.
the thought was basically I have my sort of high level IR. This is a tree IR. It's basically the AST with some cleanups. And then I have a mid-level IR, which is a linear graph-based IR, like the usual basic block stuff. And I was trying to sort of figure, okay, at sort of what point between those two should I start specializing types? Should I do this as part of lowering to that mid-level IR so that in theory I can do everything in one pass?
Your ASTs have function calls directly.
Sorry?
You specializing at function call boundaries?
So I will be specializing, yes, functions and types in a more restrictive setting, in the sense that within my language, the majority of data will be addressed through pointers, because the type system specifically allows you to move data around while references to it still exist, and that is only possible if the data is in a stable place, e.a. the heap. So the default is pointers.
How would you specialize with pointers? Is indirect call? What would you specialize for?
So what I was going to specialize over was essentially ownership. So if I pass some value to a generic add function, the types of ownership basically owned in the Rust sense. Once you're done, it gets cleaned up. References, both mutable and immutable, and they're the same thing code-wise. Then I have strings and two other data types that use atomic reference counting, and integers and floats, both of which I want to pass around without boxing. So there's let's see, owned, atomic, int, float. There's like 5 types
in what sense they are specializing?
So memory layout for most of those will be the same, in a sense that because my integers are 64 bits, so our floats, they're all word sized. It's mostly the code within functions, because for these different types, creating and disposing of aliases requires slightly different code. So if I, for example, create a reference to some regular owned value, that incurs a reference count increment. But if I create a reference to a string that uses an atomic reference count increment, or if I create a reference to an int, it doesn't actually create a reference, it just copies it. So the code you generate for functions is different whenever you create or dispose of aliases.
So for
in
the
between,
base
it's
types,
largely the same.
Did I get that? It specializes for the base known types.
Yeah, so there's a paper, I believe, that discusses it. It's called kinds are calling conventions. It does something kind of similar, where they basically say specializing across types is great, but there are a lot of types that can be sort of grouped together because they have the same memory representation. Classic examples: if you address everything through pointers, then an array of users, an array of cats has the same memory layout. So my idea was there, because in my language you predominantly have pointers. The main differences are how you create and dispose aliases. Right now I do that at runtime. I basically use pointer tagging to figure out, hey, is this a reference, owned, whatever. But then every time you have a generic function that creates, say, a reference, it basically has this if thing going. It's like, oh, if it's a reference, do it this way. If it's a string, do it that way. If it's etc. So my plan is to specialize over that, and then eventually in the future extend that so that in certain cases the compiler might say, hey, this type is small enough so we can stick it on the stack, and then we maybe specialize over that. So I call those things shapes, because naming is terrible. Some people call it kinds, others shapes, whatever you call it, doesn't really matter, but layouts, whatever. But so as far as doing that, there's a few ways I thought. One is you take your high level IR, you type check it, you do whatever. And then before lowering that to the IR where you run your optimizations and whatnot, you run an extra pass or multiple that go over this high level IR and basically go through all the types that are annotated and specialize them and sort of replace them with their new versions. So if it encounters an array of int, it will say, oh, actually, we have to replace that with an instance of the array of int class. So of this sort of generic base array class. The second is basically you do that as part of your lowering to your mid-level IR. The idea being like, hey, we have to, as part of that pass, walk over this IR anyway, so might as well combine it. And the third is you do it afterwards, where like you lower first and then you sort of fix everything up. As far as I know, they don't really have like necessarily benefits over the other. I think that's kind of my challenge. Like, okay, which one do I pick? But then sort of sketching that out, I realized you probably need actually 2 passes at least. Because in one pass, you will find all these types and you will specialize them. So array of integers becomes array of int as one class, for example. And then a second pass, you would have to specialize functions. Because how you specialize a function may depend on the type that it is defined on.
This sounds highly co-recursive.
Yeah, so essentially like the simple example, if you have a push method on an array class, how you specialize that depends on how you specialize the array class. Because push itself is not generic, like it doesn't define generic arguments, it just sort of captures them from its receiver.
But you mentioned you have the array, the generic version array for ints, which is int array, and you have a class, you have an implementation for each of the base methods, let's say, and you substitute on the code side with the most known special class of arrays, correct?
Yeah. And so that would be the idea, but that's where you already need like 2 passes. Because if you do it in one pass, you get ordering issues where I don't know if ordering issues is right. Would you leave behind a sort of impartial state? In the sense that if I encounter a call to saying it correctly, actually. No, actually, I think you can do it in one pass. Now that I think of it, I was thinking of the case where you encounter like a method called on a generic type, but then the type itself is specialized later. But I realized just now, like, hey, if you have the expression x.y, meaning call y on x, you would specialize x first anyway. So now that I think of it, I think you can probably do it in one pass, actually.
So I believe the specialization is done for each call set. You have one generic function, and it gets called in a lot of different contexts, and that each context has to be specialized like separately.
Right. And so my idea there was at both the type and method level, or put it with the structures you use to represent your types and your methods in your compiler, they would have some sort of mapping where you say, hey, for each of these type arguments, this is the specialized version of that thing. So my current sort of proof of concept, that's just a hash map where the key is an array of the shapes, the type arguments. So if I pass, if I have an array of integers, the shape of an integer is int, very creative. But if I have, say, a function that takes an owned value, a reference, and an int, the shapes will be owned ref int, for example. That would be the key. And then the value is your specialized class or your specialized function. And then my idea is to basically do that lazily. Like you encounter, let's say, a function call. You check, hey, is it generic? Is it defined on a generic type? specialize that. That process creates the specialized class for it. And if it already exists, it would reuse it. And then as you specialize the function the same way, the result is either, it's the same, there's no specialization needed, we leave it, or we did specialize it, here's the new ID pointer, whatever you use for the function, and then sort of swap it. And so you would end up with, array.push turns into something like array of int.push1, where push1 is just the first specialized version of that method. But it's funny when you talk out loud about it, you answer some of your own questions. So
we're glad we're here.
Yeah, but that's also partially why what I've been doing this week. I've been sort of sketching it out, but in parallel to that, just doing a lot of other things. Because I know from these sort of things, whenever I start a sort of next big task, usually the first week or so, I'm very chaotic. Like I'll try something, I'll be like, oh no, that's terrible, sort of wipe it out. Try something else, realize, hey, that first thing was actually not so bad, go back. So this week is like, you know what, I'm gonna take a step back.
So the specialization, would it be, you
Yeah,
said you'd be something like push one. Would you get into a scenario like a C++ naming the types as part of their monomorphization, if you will, to get a copy of function with each names, which encoded the type in the.
So my current idea, as far as sort of naming these specialized versions, my plan is to just take the base name. So in case of array, that will be array, and you just stick a number at the end. So you don't get like array of int or array of string. It's just array 1, array 2.
What about the return types variation, which encoded the type itself? Would it need it to be encoded?
So as far as like the generating the names, I don't think it really matters there in like what name you use, as long as it's unique.
Yeah, you just have to disambiguate it. C++ does it.
Right. So my idea there is basically you take the base name, you take a number, the number is basically the number of specializations for that base thing.
Oh, right.
So if I have let's say if I have like an array of ints, floats, and strings, there's 3 separate types. This mapping of shapes to classes essentially would have a size of 3.
Yeah.
So int, float, and string all have a different shape, and they would point to like array 0, array 1, array 2, and you
have to know which specialization you call for the.
Yes, that would be based on the shapes. Yeah. So there's basically a lot of hashing going on where you say, oh, for this type of this function, its shapes are this. And it will look up whatever class function, whatever we have to use. That's the one we use.
Yeah.
And so there, my idea is basically if you do that as early as possible, everything after that sort of carries on automatically. In the sense that the IR doesn't really care if it's calling array.push or array1.push1, as long as the types and methods exist, and no problemo.
I think.
But there are things where I haven't figured out, like dead code removal or like specifically unused functions, because if you specialize, say, array. Probably because it's such a common type, you'll see it specialized over every shape at least. This is probably worse if you specialize across types, because you might end up with, like, let's say 25 versions of the array class.
Yeah.
You need a way to get rid of methods that are unused. But this poses an interesting problem where if a language didn't have inheritance or interfaces, this will be trivial. you basically go through all your call sites, you flag, hey, we've used this method,
Okay,
and
but
then at the
that's
and then at the,
for the executor. But if you are in the library, but how do you know?
right. In my case, it's not really like a core part. Yeah, right now I essentially do a whole program optimization, compilation, whatever you call it.
Optimization? Yeah, no problem.
In the sense that I don't have intermediate compiled libraries.
Mhm.
Yeah, in a library case, you would perhaps only remove private methods, for example, that
You
are
can,
used.
right, in the library case, you could just add a bogus use for
Right.
the external caller who is yet to appear.
Right. But then you get into interesting case where if you have dynamic dispatch
Yeah,
through trades, whatever, things get difficult. Because if I have my, my array, let's say the pop method isn't used in static dispatch, but I cast this array to some interface that ends up using it. The compiler might not be aware of that. And so it might incorrectly remove the pop method, and then it will explode at runtime, or I guess link time, because it won't find this symbol. So,
anybody who can call pop and under an interface can call any pop on anything under interface rules.
yeah, so pop may not be the best example. Let's say toString, because in my language, for example, toString is typically introduced through
I
interface.
wouldn't delete toString under any circumstance in case you ever get hooked
Right,
onto
but
a bugger.
Essentially, like, it could be any
Yeah.
method introduced through an interface. Like you have, say, string implements it, a bunch of others, right?
Yeah.
If I cast, say, string to toString, and I only use that method through that interface, the compiler wouldn't know if the toString implementation for the string type itself is used, because the only call sites are toString on this interface.
Right.
So the idea I had there was you can take the conservative approach where you say the compiler only removes unused methods defined directly on classes. So if a method is introduced through an interface, it will just conservatively assume it's going to be used, and so we have to keep it around.
Another question. Isn't an interface basically a set of the classes that implement the interface, and then as you're specializing the program, maybe that set gets smaller?
We
But
talking
like
duck typing? Are we talking?
Well,
static typing?
I'm just thinking from the compiler perspective, regardless of the language, like as you're figuring out the program, like wouldn't you be able to gradually narrow down?
That's what I'm saying.
I would think that you'd want to try and figure out which types you're calling, whatever function it is against anyway, and it's not real, like it's only at the language level that you're calling against an interface.
So okay, at link time prior to runtime, the set of things that are named interfaces you'll know, and that's conservative in the sense that somebody may never get used as a named interface, but if I have a named interface, I can assume that I'm going to come through somebody and get it via the interface. Yeah.
Well, I guess if there's basically if there's foreign code that your compiler can't see, then you have to be pessimistic.
You have to be really pessimistic, right? Same thing for like Java class for name. Can I delete whole methods in Java? Well, class for name, so somebody appears and calls it. So they don't have a closed typing system model. So I don't know, at Yorick, if you have a closed typing system model, it's probably something you can do there.
No, so I don't have anything like sealed classes or anything like that.
Right,
So
but you did say you're doing whole program compilation,
Yeah,
so you
that's
do
right.
kind of know all the sources at compile time.
And so, like Darrick said, you can sort of narrow down the list of suspects, so to say. So when the program starts through the type system, it might know, oh, the, toString interface is implemented by these 15 classes. So by default, we're not going to remove that toString method. But then through, you know, your optimizations, it might find out like, hey, wait a minute, a bunch of these classes are never used, or maybe none of them are used, and then, you know, in theory, it could remove it.
You got
But
the
my
whole
thought process basically, yeah, if a method is introduced through an interface, we just default to leaving it as is.
I'm doing a whole program called graph analysis, which is just another, I mean, it's the same linear path as everything else, but it'll track who calls whom, conservatively, of course, but maybe more sharply than an interface got involved. But I don't have any code yet, so I don't have a problem with large method, whatever. You're doing dead code elimination on functions here to decrease your binary size. I'm taking it.
So right now I'm not doing any, but the idea is, yes, if you specialize at, let's say you specialize a type of 500 methods 3 times, right? 1500 methods. That's 1500 methods. You have to optimize, lower to LLVM. LLVM is probably going to choke on it, generate native code for, etc.
Welcome to Julia.
And so ideally, somewhere early on in the pipeline, you want to get rid of, or at least gradually get rid of more and more.
Right. You're trying to speed up your code gen by nuking things. Yeah, fine. And that's because you're specializing sort of aggressively across.
It's not so much. So I think in practice, like in this initial implementation that I'm working on, there will not be any code removal. It will just be specialization, which means larger binaries, larger compile times, whatever. That's a separate problem, basically. And therefore, static dispatch, it's fairly straightforward. Or specifically methods defined directly on classes, because they can only be called through static dispatch. Or from methods implemented through interfaces. So there does need to be some analysis where you say, oh, we have this interface which calls this method that is defined directly on this class, so then we have to flag it as being in use. But I think that sort of basic level of analysis is probably not too difficult to implement. It's just it has to be conservative by default.
Yeah.
But I was trying to find out like how other languages do that, and it's surprisingly difficult to find answers on.
Yeah, I'm doing the optimistic version on the when I have it. Well, it's optimistic always, except that if you're doing a library, you have a main dude, which is the external caller, who immediately reads all and writes all and crushes all your optimizations anyhow. Yeah, I think you're right. I think other folks play a very conservative bottom-up game. I'm trying to think of what I'd done years past, link time optimizations, and many years ago, it was always bottom up. Java never threw away any method definition. Now, you only did bytecodes, so there's no code gen issues you're going through, but you never threw any away.
Yeah, I think that's a benefit if you have a JIT. I wouldn't say this isn't a problem, because you still have a large pile of bytecode that sort of gets loaded in initially.
Yeah.
But if you only JIT what is being used, you don't have to worry about removing what is not used, because you don't JIT it in the first place.
And you don't have to specialize all variants up front either. You specialize on use.
Right.
So you'd get some fewer number of variants as well. Yeah, you're doing static. I think you have to be conservative there. So this is like tree shaking. Is like, what's the difference here?
I think tree shaking is just what JavaScript called dead code removal.
Okay. Yes. Fine.
Yeah. Everyone who said it tree shaking is fired.
Is what?
Is fired. I'm just joking.
Okay. Yeah. Fine.
Earlier, Yorick mentioned doing FFI. I was wondering, are you doing anything to prevent the other language from like blowing up? because I remember Java using handles, or that's what
Yeah,
Cliff was
I was gonna ask you
saying.
about garbage collection handles and foreign functions, yeah.
Yeah, so are you doing anything like that, or anything to prevent it from blowing up?
Short answer, no. I don't have a garbage collector, so that does you don't have this issue where you hand out a pointer, the GC runs and is like, oh, I don't have reference to
Hey,
it
see you
anymore,
out
you know,
there.
let's get rid of it. But no, there's nothing stopping you from okay, back up. The FFI itself, like, you know, it does allow you to essentially pass arbitrary objects to C. I thought about restricting that in the sense that you could only pass essentially primitives to C, like int, float, maybe pointers, that sort of thing. But if you have like an array of users, it would say, but then I ended up actually needing that to implement certain low-level bits of my standard library. But so as far as memory management goes, no. If you pass, you know, some data to C and you then release that data, C will still have that pointer, so it will have a, you know, use after free problem. I couldn't really think of ways to solve that other than this mechanism in garbage collected languages where you have to like root a pointer when you pass it. In theory, because I have reference counting, what you could do is increment the reference count before you pass it to C. Because if the value is then dropped, it will check the reference count and say, hey, there's still a reference, kaboom. But then you either, you know, add a cost to passing values to C. And I also found you mostly are not passing references to C. Instead, it's mostly C types that you get back from C that you pass back, or it's primitive types like int, floats that are copied anyway.
Network IO and
right, or pointers.
well, I mean buffers of data. You have pointers to the buffers. Who owns the buffer?
So that's the case where you have to be careful. The way I sort of approach it in my docs, it basically says, you know, don't use the FFI unless you really, really have to. And then further down, it's again a warning that basically says, seriously, you don't use it, because essentially all the safety guarantees, they're thrown out of the window.
So you mentioned you have a ownership model. So if you have an FFI, you don't have ownership model inside.
So essentially the safety, the ownership, that all stops at the FFI boundary. So if you so there is you can pass, you know, let's say you have an array of users, you can pass that to C. But
I'm wondering,
then if you
can you supply C methods that can somehow implement the ownership model, saying when I return it, I don't own it. Maybe it's a value, extra value in the function if you call a C function, so that somehow you have to re-implement the tracking the ownership calling from C to your code.
Well, so the thing is, if you have, let's say, a C function and you annotate the function as saying, oh, this function takes an array of users. If you specify that as being an owned value, you pass it. That value is marked as moved. So then it's up to C to eventually pass it back, release it, whatever, right? If you pass it a reference, it will increment the reference count. So if you pass a reference, then drop the value, it will error because C still has that reference. So, and then the third thing is, given an object in my language, there isn't really a way of getting a pointer to it. There are exceptions, strings and byte arrays, because I need that for sort of low-level bits. But if I have an array of users, there's no sort of publicly exposed method to get a pointer to that thing, which you can then pass to C without sort of any ownership being enforced. The way you'd have to do that is you have to cast the value to the special any type, which you then have to cast to a pointer, and that you can pass to C. There's nothing stopping you from doing that besides that it looks quite ugly, kind of by choice.
And you drop all your type system on the floor?
Yes. So again, that's kind of tricky if you interface with C. Whatever nice little safety guarantees you've made, this little universe that's all perfect, that's get shattered. Like it ends the moment you
Yeah.
throw it over.
One of the things I was attempting to do, I didn't get much time to do this week, but I wanted to generate C++ headers that have classes that prevent you from doing things like holding onto a copy. There's something called it's an experiment class observer pointer, and if you put that type in the global space and then you assign a local variable to it, it happily does it for you, and that's the thing I don't want it to do. So I think I got to write my own type. I'm just going to be attempting to generate wrappers and then tell people to use C++ instead of C. So hopefully it will catch some errors. But I'm still not sure how well that's going to go.
So I don't know. I mean, does the FFI support C++? Is that something you're aiming for? Yorick?
No. It only does the C API. I'm not going to bother with like demangling C++ symbols.
Okay.
So ultimately my goal is there to write as much in the language itself, rather than what you've seen in a lot of other languages where.
Well, then just don't have an FFI at all. You don't.
So I
That's
was
what I
leaning
prefer.
towards that, but there are unfortunately certain libraries that I will not be re-implementing the next 10 years that are kind of necessary. Like SQLite is a very popular library, for example.
It's like, I don't know. I mean, every language I've seen, they want to have as much interoperability as possible. So like they have these Clang-based implementations where you just import the C or the C++ header, and then you can use it, all the functions and stuff.
As easy as it is to interop, to me, it seems like most languages aren't easy to interrupt with other languages.
Well, yeah, that's because they didn't put in the effort. They aren't. I mean, they're like your language. They're trying to be unpopular and hard to use. Sorry.
So I think
no
in my
one
case,
has told me hard to use.
like in my case, I'm more taking a approach kind of like Java, where yes, it has an FFI with C, but it's kind of there's like a last resort. You really should be writing things in Java instead. And I'm taking the same approach with my language because Interop is nice, but I also think it's overrated. Overrated in the sense that a lot of people are like, oh, you need it to succeed. And I'm like, well, not really. But also,
I agree with you.
Interoping with C, it really infects your language. The safety mechanism, all of that's out of the window.
Mhm.
But to interop with C, you need different sized integers. You need pointers. You need to be able to allocate memory on the stack and pass a pointer to it, because some C functions expect a pointer that they can write into because they return an integer. So it's a result,
You
right?
don't allocate memory on the stack. You allocate a stack. That's what Go does.
No, but
the C stack.
my point is more that if you want to have excellent FFI with C, you are essentially building a C-like language. And that's totally fine, right? There are plenty of languages that do that and do that very successful.
How about a wrapper? How about a wrapper? A wrapper around the C language, which is write it in your own language, but inside it wraps lots of functions.
Right, so that's what the FFI is essentially for. Like you want to use SQLite, for example, right? A lot of libraries you can re-implement. Like, for example, my plan is to write an entire TLAS stack in my language because I am absolutely not binding to OpenSSL. And because it's kind of cool to say you can do that.
Yeah.
But for example, SQLite, it is written in C. Yes, you could theoretically rewrite the whole thing. Some people have done that with Go, where they've taken the C source code and sort of converted it into Go.
Mhm.
Mostly because the Go FFI is fairly heavyweight. I don't want to do any of that. I'm like, we have an FFI, it's basic, you're on your own, but it's good enough so that if you have these, let's say, core integral, whatever you call it, libraries like SQLite or NaCl for cryptography, yes, you can use those. Just beware that sort of the boundary between C and Inko in this case, it's a dangerous area. Like you have to be very careful. You're essentially writing C just with a different syntax.
I'm curious how Cliff is. I don't know if he's still here. If how you're thinking of Interop for AA.
Oh, for AA?
Yeah.
Yeah, I'm gonna call straight into C and back. You're talking about whether I'm gonna
worried about it sort of messing up your type system or infecting your language.
Yes and no. So the easy answer is you call FFI, you get what you get. So, neener on your types. And I want to include in the typing the fact that you're calling some certain kinds of FFI, maybe up to and including throwing in some sort of SHA or MD5 or crypto key as part of the type signature. So the person who gets your library that you just wrote in AA knows that in turn, this AA code is going to call out to whatever. Going to call out to MySQL, SQLite, I don't care. Going to call to hack my machine, right? So the call through, like if I only call in the AA code and it's type safe all the way down the line, there's no shenanigans possible. If indirectly through AA, I get to call out to an FFI, then whatever the FFI does is included in the shenanigans that you got through AA. So I would like the AA type system to say, and this AA code calls something that's now going to be in your trusted computing base. And so your trusted computing base includes everything AA can do, which will be capped by the typing system for AA, plus whatever the FFI can do, which is like, sky's the limit, Go read all your security keys and crash your machine and whatever it's going to do. And then, somebody on the other in the line of using this says, well, my FFI I'm going to link against is going to be BLAS routines, or I'm going to call SQLite or whatever. And I know what it is and I'm okay. And I don't care. That's fine. Right. Whereas if I got a static link job that says it was at AA and called from AA, but the AA type signature internally said, yeah, and I called this other weird link thing that, I got linked against, but I don't know what it is. That should be obvious in the types. That's something I want to drag out and have it be clear.
So like you'll have like a sort of shenanigans mix in, and anything that you've gotten from a link from a FFA call will permanently have shenanigans.
Yeah, I think so. And I think that's I can put more refinement on that and include, the names of things or whatever. There's some stuff can be thrown in there. But to be secure, eventually there has to be some sort of crypto key thrown in there.
But can't there be couldn't I call some unsavory C code that went around in my own program's memory and like messed things up?
Right.
So, it's not like breaking any segmentation fault, but it's still messing with something that like the AA thinks is pure, but now it's not.
Yeah, that's what Java happens too. You call into C code from Java, you pass it a handle. Well, everyone knows what a handle looks like. You peek through the handle, it's a pointer to a Java heap object. You hack the heap object in the JVM heap. You hack a string, which is supposed to be final and unchangeable. The string is your password key or somebody's password key or something. I mean, any number of things. So this is always true as soon as you call FFI.
Right.
And this is always true when you cross the trusted computing boundary. I mean, that's one of the major reasons for PGP or whatever, public key private key thing was it lets you obtain trust across boundaries that other people, that couldn't do, right? So here it is. I got a boundary I'm crossing.
Yeah.
What kind of trust can I make? Well, at some point, I have to just trust the thing that I'm calling is okay, and then recursively it backs up, and then I trust who trusts. But it would at least be nice to have a record that says, at the bottom, at the base, your trusted computing base includes everything that I can get out of SQLite or whatever I ended up calling.
Is there any way to, this is not really relevant to anything I'm doing, so I'm just out of curiosity, but is there any way to have a kind of sandbox to say, I'm creating a call to this foreign function, but everything that it does, it's illegal for it to try and do anything to my memory.
You have to cross a protection boundary, hardware protection boundary.
Mm-hmm.
That's kind of how I got around Clang and TCC being single threaded. I just threw it in another process and then just pipe my data in and out. Worked.
Okay.
But I guess that's pretty slow in terms of invocation.
Yeah, getting that process up, crossing the boundary once it's up's not too bad, but getting it up's got some overhead. Yeah.
Right.
I'm not sure how true it is on recent Linux, but no.
Finish it. Oh.
Yeah, I mean, like the safest FFI is probably a RPC system of sorts where you essentially have two processes, one running your own language and then one running C code, and you communicate through some sort of message protocol. But that don't only work if the data can, in fact, be serialized to something that you can essentially send over the wire. Or you have to start communicating with handles. So if I, let's say through some C function, if I allocate some memory, I don't get back some sort of serialized pointer. I just get an ID 52. And then I have to remember hey, whenever I want to use that pointer, I actually have to give this ID. But you end up with an FFI that has a really high cost, I think.
To my understanding, WebAssembly is working on safe interoperability between different programming languages, and it does have a component model, capability to base security, like someone has mentioned. It can indicate which functions you are going to access. Maybe it can be thought as a form of lightweight sandboxing. So if you are targeting WebAssembly, that may be one way to go.
Well, we have one in the middle.
You're fading in and out a little bit, and I didn't understand everything you said.
He was saying capability based. Use capability based.
So is that something also like a kind of protection mechanism?
It is. It's from the outside. You define what the capabilities are, and then if you don't specify a capability, then that capability is inaccessible by definition.
Right, but that's because the WebAssembly is
sandbox,
kind of like an interpreter that's running inside your process. It's not like running direct. It's not like running compiled C, right?
Well, it is
what it's doing, and then deciding whether or not things that it wants to do can be done.
It is like running compiled C. That's
I'm confused. I have a native library that does video codecs or what the hell it does, and I want to call it.
Okay.
Okay. Am I calling it in the same process?
Well, you from WASM you can't call a native library.
Okay.
But you can compile that C library to WASM.
Yeah, I don't have the C library. I have the .o file, which was hacked by a hacker and actually calls out to Alibaba and hands my passwords over. So, I don't have the C source code, and I don't know what the hell the library does, but it claims it does a video codec thing.
So WASM doesn't help you with it. I mean, that's the point. You can't can't have both worlds. You can't have an open universe and security.
Yeah, fine.
You can pretend. Java does. C++.
I was under the impression that somebody was believing the capabilities were going to give them open universe and security.
Open universe, if you have source code, sure.
Yeah, source code, yes.
Matt, did I butcher what you were trying to say, or was I close?
Kind of close. I mean, I'm not sure if my mic is working right now.
You're working fine. You're good.
Okay. But basically, I mean, WebAssembly can be thought of as an IR, like LLVM IR. So yes, you would be using a source code to compile to this WebAssembly as your target. And on this level, you can implement some kind of component-based safety interoperability different parameters.
Yeah,
But this WebAssembly is compiled to machine code after that, so it's not as if it's interpreted or anything.
great. So WebAssembly is compiled to machine code in the same way that JVM bytecodes are. In fact, a lot of the same people that worked with Cliff are working on the backends for WebAssembly.
It's the right one everywhere. Somewhere.
Yeah, the reason I said video codecs is they all use x86 weird special ops that no JVM JIT's going to emit. So it's not a source code compatible thing. I can't just pick up the C source.
I think you're underestimating Arthur.
All right, fine. Maybe. No, he bailed out. But yeah.
I know you bailed. But yeah, I mean, that's definitely been one of the hard bits in backends is how do you take advantage of these great instructions when you have these amazingly
you're trying to prove the code is both secure and maps directly to these hardware instructions that will accelerate it, tenfold. All right, I'm gonna be AFK again.
Me too. I have a bunny I have to go rescue.
All right. We can talk about my definition of OO again. Or chat GPTs rather. I don't know. So, or what else can we talk?
Well, I have something for when Cliff gets back, because I wanted to ask some specifics about register allocation and sea of nodes, specifically like when you insert splits, like how do you?
Okay, well, he's not here, so don't ask it.
Yeah, so yeah, so I'll try and ask that.
Okay, so I'll talk about my own.
Yeah.
So the definition of object-oriented programming is that A, you use objects to manipulate and represent data, and B, you have encapsulation, inheritance, and polymorphism. So that's the definition that ChatGPT came up with. I don't know. It works. It's not like it's a terrible definition.
I think the problem ultimately there is that people haven't come up with a better name for these sort of different categories of OO. I think probably the sort of best analogy is let's say Christianity, right? We have Protestants and Catholics, for example, and you can refer to them as Christians as a whole, but there are differences. People might argue about those differences and get very heated, but
I think that's the point. Is you don't have to look at the examples. You have to look at the word. The word is Christianity. So there's Christ. That's the definition.
Right. But so in the context of OO, like there's these sort of different, let's say, movements within it. And if you refer to all of them as OO, you will inevitably piss off some people because you're like, no, this is not OO. OO has these rules, blah blah blah. So my point is they're more like perhaps instead of referring to it as OO, we need something else to refer to these different styles. Now, obviously, naming is difficult, so there are no alternatives that I am aware of. But for example, the original sort of idea as proposed by Alan Kay, I think message-oriented programming would probably be a better term because it better captures what it originally was intended to do.
At least to me, the essence was you have in some encapsulated space and you talk to outside world only through some kind of messages, something like the system calls are perfectly describing what is exactly what there there can be thought of reducing complexity. There's such a things that I will accept and respond to. That is a way of encapsulating. So at least to me, I understood it like that.
Yeah, and I think the best modern example of that, and this is probably going to annoy some people, is HTTP. The second most OO language is probably Erlang, which is a functional language. But that's because they use messages. You don't know sort of the internal state, how it does its things. You just send a message, get a response, right?
Yeah.
But so that's I think coming back to what you discussed in Discord.
And here, I want to make a point here. I want to make a point here because the Yorick is quite on track. The point here is how generic is the message. As long as when you start specializing the message, you start restricting the outside environment, how you can respond to. So if the message is something that whole universe can encapsulate it, then you don't have a really message per se. Then you have a open channel, if you will. But if the message is quite restrictive in what it accepts, and let's say it's liberal in what it returns, it doesn't concern it, but what it accepts, if it's specialized enough, then you are setting a boundary from which you are receiving information.
Yeah. Yeah, Alan, did you want to say something?
Oh, well, I was just wanting to say that, like, you know, I mean, I don't think many people would agree that Erlang is object-oriented. I mean,
Well, it is in a sense that you have
right.
processes.
It's an Alan Kay's sense that you were talking
Right.
about. I don't think anybody would agree with Alan Kay's definition at this stage.
No, but that comes back like we need better names for it, right? It's kind of similar to how in functional programming, you have purely functional programming and functional programming. I don't know what the alternative name will be, right? But they're different styles and they have similar roots, but they're not the same. And so Alan Kay's approach you could call message-oriented programming. I guess the Java C++ approach, you could call it, I guess, class-based programming. It's not a great term, but it better captures this idea that you have classes and inheritance and all that stuff.
Objects, not object-oriented purely. There's classes.
So Alan Kay explicitly says that he never, ever described object-oriented programming, and that's something other people made up. Alan's point was he does object programming. Everyone else does something else, and they call it object-oriented programming, and it's wrong according to the Church of Alan.
Ah, see. I'm now curious what Alan thinks everyone else gets wrong.
It's confusing to me because you keep talking about Alan.
Oh, sorry, Alan.
Third person.
You
Well,
can
the
be our
Alan-
resident Alan Kay if you want.
There you go.
All right.
All right.
Well, I have one question that I just wanted to ask how you approach, Cliff, when you're inserting like splits, or especially when you're splitting ranges in the register allocator. How do you insert those? Do you like, because when I was looking at that, like I have the scheduled graph and I can sort of insert before or after the instruction I'm interested in, but do you not run the scheduler again? Because when I tried running the scheduler again, and then I end up like the splits and going to the wrong places kind of thing.
Right. Okay. So even in the register allocator where I have names for everything, I have SSA, I really have graphs with edges and nodes, and they're forcing ordering. So the scheduler can't fuck it up that way. However, the scheduler can screw up the range which things are live over and cause a colorable graph to become uncolorable yet again. So I don't run the scheduler after inserting copies. So the theory on the scheduler is that it does a good job, not perfect, and I should take it as a nice starting point, and I don't want to screw it up too much, but I'm allowed to screw it up. And then the register allocator splits live ranges, and wherever he decides to break up a live range at, he inserts, I called it a spill copy, a copy instruction that can target both memory and a real register, and that will go back and forth according to whether you're down in the stack or you're up in a register. And that splits the live range and inserts an op into the schedule. And then I don't reschedule, that the op is just right there. And it's always like right after a def or right before use. So it minimizes the length of time I have a particular live range that I'm trying to split or left live. You know, I got a stupid x86 multiply left or argument in racks. Well, I need racks for something. I'm spanning a call or whatever. So I spill immediately after the multiply. So the racks goes down to the stack and is immediately available on the instruction after the spill code. And that's the assumption the allocator works on. Same for all calling conventions where all things are fixed registers and everywhere you end up spills all around those places. Periodically, you'll get multiple spills in different rounds of spilling at the same point, but they're always in reference to a different value, different named register, so they don't ever have conflicts. Like the scheduler can accidentally move a spill op far from the def point that you're trying to get rid of the racks, and the multiply and the spill are next to each other. If some other spills are right here, it spread over a couple spill instructions, but those other spills didn't talk about racks, they didn't care. But if an arbitrary scheduler took the spill and moved it far from the rack spans a long ways. If it spans something that needed racks, then you're in trouble and you spill again. Right? So you don't let the scheduler get in there.
Yeah, okay. Yeah. All right. But you are still doing it with the graph, and you're still keeping the graph valid.
Yeah. And that's so you can walk the graph, you can say dependencies and this and that. Post allocation, I will walk again the graph using a local, like a linear scan, looking to get rid of copies. Like I have everything colored and it's all fine. I will do a strictly monotonically remains coloring after every step version to get rid of more copies as a one pass linear scan.
And when you're doing that, how are you able to follow def use edges to do that, or?
Exactly the reason I'm keeping the graph is I can follow def use edges now.
Yeah. Because the problem that I have is that I go from the graph to a non-graph representation, and then it's so annoying to when I'm looking to get rid of copies and stuff. I end up having to sort of do this n-squared scanning.
Right. Yes. Exactly.
Look around, and I was thinking, okay, I just need to sort of stick graph nodes back into there so that.
I mean, all I have is graph nodes, so it's always graph all the time. That's even down to instruction selection and instruction emission. When I go find what the registers are for a particular input guy, I look at his defs output registers, so I follow the use step edge and pick it up there.
Yeah, because I still have a sort of chunk of my backend compiler is still based on the original NanoPass part.
Right. Yeah.
So I have.
So when do you drop the graph, Cliff?
Never. When I throw the code into the code cache, x86 ops, and I am done with the compilation. That is strictly. It is all the way out through. What are you thinking?
No, I just again, I haven't implemented it.
But you've for quite a while towards the end, I guess you've got the graph nodes, but you've got arrays of graph nodes in order and like blocks, different arrays for different blocks or whatever.
Yeah, I start adding the nodes that also carry the basic block marker, and then there's I forget, I think it is an array hung off of the head of whatever node represents the basic block marker. It's a graph node, and he's just got a shortcut to list everybody. So he's effectively pointing at everyone in the block. So I pick up extra structure toward the end. And I just marry it with the existing graph nodes I have, but they're not really graph nodes per se. They're or control flow graph. They're not same thing.
Right. Yeah.
Oh, and I'm going to run
Okay.
away because that's what happens here.
Yeah. All right.
You bravely ran away.
Yeah. Cameron, you've done register allocation stuff too, right? Haven't you? Or-
No, actually, I haven't.
Okay.
So, because I've never done a back end to native. So I've done assembly, but the register allocation is done for you by the author. So all you're doing is translate, like it's brain dead simple.
Yeah.
It's linear time register allocation, let me tell you.
Yeah, right.
And it's perfect. It does exactly what they say. And then in the higher level languages, you never do it. You're just producing IR. So
Right. What's your target like runtime?
so originally we had looked at LLVM.
Mhm.
And for a number of reasons, some of which you've heard on these calls from other people, we just moved away from that as a possibility, at least for the foreseeable future. Then we looked at a couple others, including WASM, and that was actually fairly attractive, but the whole community blew up over the whole WASI thing, and we needed
Really?
that. We needed that support. So yeah, I mean, they kind of went AWOL.
The community
So-
blew up over what?
Well, there's a faction that only cares about WASM in the browser, and there's a faction that thinks anyone that uses a browser is a fucktard. And so,
How do those
and-
people get with each
and
other?
they get along really well because the ones that are not browser oriented like to tell the people who are browser oriented what morons they are. And then the browser people get really upset because they're actually solving real problems. And
Right.
so, and the whole thing blew up, and it's way too much drama for me. So I just
So okay, so then
so we're actually targeting Java now, which is one of the reasons why Cliff is involved.
right.
So
Okay.
so we're going to use JVM bytecode as our back end and let C2 pick it up from there.
Oh, cool.
And that should carry us a number of years. I mean, should be more than sufficient for what our needs are.
Yeah. Anyway, I'm sure there's a JVM bytecode to WebAssembly compiler already. Anyway.
It's certainly feasible. They're not actually that crazily different. Yeah, I started actually before the WASM. There were actually two versions before WASM. The initial one was called ASM.js.
Mm-hmm.
And basically all it was is you put a header on your JavaScript files that says, I promise not to do anything bad. So there was like a spec that says, if you only do the following things in JavaScript, put this header at the top, and then V8 will optimize it more aggressively. So basically there's no eval, and there's a bunch of stuff you had to avoid, right? And then there was another one like that was like a little further along, and then WASM came out from that project. So yeah, I was, and this was actually back before I started the Ecstasy project. So this goes back probably before 2010, so 2008 or 9 timeframe.
Yeah, I remember following some of that stuff back in the day. I have sort of vague memories of seeing that stuff too. I was doing ClojureScript and building web apps and stuff like that. So
yeah. So but yeah, so right now Java is our target backend.
Okay, cool.
It's not ideal, but it's reasonably good. And one of the things that made it a lot more attractive is this Project Loom that they've done, which supports things like the virtual threads, for example. We absolutely required that. So
Okay, yeah.
And
Yeah,
actually, that's the reason why we couldn't use WASM, is because when the drama happened, the a lot of the WASI stuff got dropped on the floor because that was the interop between the server functionality and the client function. So basically, those were the APIs that would let your code be portable in and out of the browser.
I see.
So, you know, had they not all gone dysfunctional, the net result would have been that you could write code, target WASM out the back end of the compiler, and that code would run with multi-threading, with fibers, whatever, in the browser or on the server. But that they blew it all up.
So
My impression is that it's kind of blown over now and people are just keep working on that stuff now. Do you have other impressions, Henry?
Well, after all the drama, I just stopped paying close attention because, like, I had been counting on some stuff to show up, you know, and instead they decided to argue online.
Fair enough. I think my impression is that it blew over basically, but again, I don't know.
Yeah, I figure give them 5 or 10 years and maybe they'll get done what they were planning to do in 12 months. So.
I don't see many arguments now. It seems that there is just more and more stuff being done.
Yeah. No, I mean, there's some cool stuff there, as you've heard on a number of these calls. I mean, the crane lift stuff is amazing. Just when you look at how much it accomplishes performance-wise for very little effort, it's actually pretty cool. I mean,
I thought crane lift was Rust.
Crane lift is built in Rust. Yeah.
Oh, it's built in Rust, but what
Yeah,
is it?
it's primarily a backend for WebAssembly projects, but it's also an experimental backend for Rust. But its main target is to be a WebAssembly project.
Yeah.
Oh, okay. Okay.
So I kind of have a policy that if a project isn't useful within like 3 or 5 years, it's probably vaporware. And WASM is like 7 years now. So have you guys like seen a lot of projects that just wasn't useful after 3 or 5? And what's the better number?
Oh, I think WebAssembly issues that web services companies like Fastly, all of those proxy, it's already used in production.
Yeah, WebAssembly is very, very useful, but only 200 people in the world have a use for it. That's the problem. But yeah, I mean, the fact that anything advanced you want to do, you can grab C code, compile it to WebAssembly, and stick it in your website, and it runs on the browser, and it's fucking cool. Like, it's amazing. But how many people have to do that? Not a whole lot of web developers are C coders.
I tried doing something like that, but none of my code would work. And it was just a pain trying to affect the DOM using WASM. So unless you're rendering something, I don't know if it's going to be that useful.
So you can certainly affect the DOM from WASM, but it's not straightforward. Yeah, I mean, it's all standard stuff to do that, and people do that. But that's like the FFI from WASM.
Is it calling get JavaScript code? Because that's the only time
generally
what
you do is call JavaScript code. Yes.
Yeah.
Or I think you can render directly onto the canvas, can't you? Something like that.
I think so.
I've seen some high performance canvasy things like 3D rendering with WebAssembly.
But basically your get out of jail free card from WASM is always calling JavaScript from it.
Yeah.
Yeah.
And you know, in terms of your however many years you were saying, I think it depends on the ambitiousness of the project. I've been planning on doing the dishes for several years, and my wife is very fed up. But you know, a space telescope can take can take even longer, and nobody seems to mind.
But you don't want the food to harden onto the lens of the telescope.
No, exactly.
So at least you want to rinse it off.
All right.
So I had another question before you ran away there, Cliff. So I realized that, well, so, you know, I basically, for the past 6 months or something, I was working on getting the optimizer working, and then got backend. And so I ended up having like all of my test programs were inline down to like a straight line piece of code or maybe a bit of looping, and there was like no function calls. But now, you know, I was like, I need to actually get some, you know, the code pieces that I'm doing are small, but they're not that small. I do need to have some function calls. So, and I realized that I somehow lost or messed up or whatever. I'm not like doing anything with my callee saved registers, and so they're getting clobbered on my function calls. So I need to fix that. I just realized that that was missing today. And so I'm wondering, do you like, I'm thinking the simplest solution to this is just at the function invocation, insert a bunch of moves for all of the, like from all of the caller saved registers, and then just put move back at the end of the function and then sort of leave it to.
Talking about how to do register allocation on callee save registers?
Yeah, I think it's a simple question, but I think that I like when I enter the function, I just need to put moves from all of those registers to a variable and then see where the allocator puts them.
I'd say, how are you allocating now? What's your allocation? LLVM?
Well, that's the thing that, like, you know, I've got somehow, I don't know if what I messed up or how it was possible I had working code before, but I don't have this in there. Like, obviously it's broken.
No,
Right?
what is your current register allocation technique?
Oh, the overall strategy, it's graph coloring, move bias.
And you wrote it yourself?
Yeah.
Okay, fine. Yes, so for C2, which does graph coloring, move bias, a bunch of other, you know, Briggs, Chaitin, blah, blah, blah. Callee save registers, I declare live on entry and consumed by exit. So there's a def at the start and a read at the exit. This makes them extremely long live range with exactly one use.
Yeah.
They're an ideal spill candidate. And on the first round of spilling, they go.
Right.
And they go with the normal spilling. I make no special effort on them.
Yeah. Okay. Yeah. So that was sort of the idea that I had, that you could make them pretty normal just by putting those.
Make them normal and then just spill like anything else.
Yeah.
And that builds you a prologue, epilogue effectively. And if you do profile-based spill locations and you have an early out function, it tests for init. Yes, your init, get out with the value. No, do something complicated. You get shrink wrap effects. He'll take the early out test and say you exit, but the live range spans the complicated shit and it needs to spill, but I won't spill it on the early end because that's a high frequency block. I'll spill it at the head of the do complicated stuff. So the function call looks like come in, maybe bump stack pointer, maybe not, test something, got it, return. That's the 99% case. Didn't do any stack moving, any spilling. Else, you know, jump into the guy. Now you get a prologue code, which is just effectively prologue because you spilled all the live callee save registers. So
yeah,
nice add-on effects. So you don't need any effort on your part, right?
Yeah. Okay. Right. So you need a special node that declares them live without doing a move, though, I guess, right?
Yeah, that's the start of the function. Has a, for me, the program start has a bunch of projections for all the live in values, all the normal live in arguments. Well, when I hit the register allocator, I also add in live in projections for callee save registers, which I treat as if they are a special kind of an argument that gets passed to every function and is consumed by the return op.
Right. Yeah. Okay. Yeah, I have projections for all the live inval stuff, and then everything as I'm optimizing gets detached if it's not actually used in the function. But yeah,
But those should be used in the function because the return's using them.
Yeah, that's right. For those I need them. I don't have those. I don't have the projections for the live registers. I have like live global.
Your arguments, which are in a set of registers typically that are miss the callee saves, right? They're unrelated to the callee saves. Yeah.
All right. Yeah, I think it should be straightforward to. I have a lot of work to do on the register allocator. It's too primitive right
That's
now.
one of them rat holes. Once the other parts of the Java C2 optimizer got decently done, I pulled money out of a register allocator on and off over a couple of years. Like, every so many months, I'd spend another month on the allocator and get another 5% speed up.
Yeah.
For better allocation. Oh, now I can inline more, and now I can allocate better, and now I can inline more, and now I get more larger chunks of code, so I can go do something else because it's more useful. But
Yeah.
kept getting more money out of the
My-
allocator.
One of my midterm projects is to study the hotspot allocator in depth, possibly.
Got ugly, but I don't think it's been touched since I left.
Yeah, so I'm thinking I may do a rewrite of mine as a port of yours, and then I can at least I'll learn what some of
I
what
would.
you-
There's some things I would say that were done that I wouldn't do again, and there's some things that worked actually really well.
Yeah.
And definitely a rewrite. Don't try to copy and make it.
Oh
go.
no. Well, because I'm doing it, many things differently, and it's done in Clojure, and it's done
Right.
with
And you had this P
everything
array
ends up
thing.
being,
Yeah.
everything has to be very different. So
Yeah.
it never. Yeah.
But there's some high level philosophy bits that are useful. That you could walk away with. All right. Well,
I got a question.
Oh yeah, fire.
Okay, so for the most of this talk, I was able to write some code and do some debugging. Last time I mentioned I needed a hash map because every time I was looking up a function or declaring a variable, I would have to look at everything before that. So I implemented that, and right now, I haven't had that much time to debug it, but it seems like most of the time is actually cleaning up the variables after they go out of scope. And looking up the members on structures. I don't use a hash table there, but I thought it would be so small in memory that it wouldn't matter. So I kind of feel like maybe something else is wrong and it's not actually what it looks like. Do you guys have, do you know anything about variables being slow or why?
Well, it's what your code's doing with the strings and the names and things. So a decent rule of thumb for when to switch from linear scan to a hash table is if you're going to touch more than like 2 cache lines worth of stuff. So if you have 4 bytes of pointer to string for variables, or 8 bytes if you're big pointers, and your cache lines are 32 or 64 bytes, and 2 of them says you get 16 or 8 or whatever the number is going to be. If you typically have more than that, you're kind of at the edge where a hash table maybe makes more sense. So
Okay,
another way to
so,
think about it is if you probe in on a hash table, you already had to compute a hash, you already had to indirect once to the table, indirect once into the table entry, you're down a couple cache lines from the get-go. So, and that's where all the money is going to go, is the cache line misses. So
Okay, I'm gonna have to write find some statistics because the function is about 20 lines, and it looks like there's around 10 to 15 variables. So it sounds like it should all fit in 2 cache lines, but
you should
it's
run
just
around,
taking
yeah.
up a lot of time.
So
So
that makes no sense on the face of it. So
yeah.
right. So a bunch of things can happen here. One is your definition of a lot of time is different than mine. Another thing is your measurement strategy is just this tiny function, and you're getting cold cache issues all the time, and you need to have 100 million unrelated copies to have enough time spent that you can measure usefully.
You know what? I did not measure the stalled cycles or cache misses. I should do that right now.
Well, that's a thing to say that you don't. Okay, here's the deal. If you're interested in the average compile speed of large complicated codes over a long span, which is what I've heard you say you're interested in, repeating the same function over and over and over again won't give you that information because you're too clonishly identical. And measuring the cold startup of a 20-line function with 15 variables also won't give you that number because it's all cold cache startup, which won't necessarily be true on a large function or large program body that I'm endlessly recompiling as I debug, edit, compile, debug, recycle. Right, I mean, my code text probably fits in L3, maybe L2, but the compiler bits are floating around. But if I'm only using some pieces of the compiler bits, because that's all I needed to compile 20 lines, I don't have even the whole compiler in my caches and stuff. It's not very realistic. So you can tell yourself that you're measuring nanoseconds on nanoseconds to go figure out how to get 20 lines faster, but that won't necessarily scale at all to how to get a 1,000,000-line program faster.
This test is taking 15 seconds.
15
And
seconds.
yeah.
Okay.
Oh, it's also single threaded because I want to
Well,
debug this.
Doing what in 15 seconds?
It's compiling, I think 20,000 functions.
Okay. And the functions are
And-
all somewhat different a little bit, or they're not just clones?
No. It's basically a copy paste, but
Okay.
but I just noticed it being slow, so I thought, there's probably something there to look at.
Yeah, that sounds unusually high, although,
Yeah.
well, it could be. And it could be that because of your way you're doing your IR, you're out of memory bandwidth. You're missing constantly for your IR, and you're just sucking on memory bandwidth. And that'll show up in stall cycles. And that'll show up
Yeah.
on any big method function, anybody who's got 100,000 lines of code. 20,000
So-
function bodies at 10 lines each is 200,000 lines, 2 million lines. You're approaching 2 million lines of code. Yeah.
Yeah, so I just ran the perf right now, and it said about 8% is cache misses on that, but this is apparently taking like 70% of the time.
Yeah.
Actually, I'm just rewriting that test right now, but
Well,
so
but cache misses
Yeah,
are expensive. So if you're 8% of total, I started a stall, I finished the stall, but most stalls are 1 or 2 clocks and the cache miss is 100, then that's going to be all your time. Yeah.
actually right now it's saying it's 40%. I don't know why it changed, but I just wrote this code, so I'm gonna actually have to like look at it.
Okay.
But yeah, it's reporting that it's taking 40% of the time now.
Yeah. So now I don't know. There's too many other things you got going on to say it's a hash table or it's not.
Yeah, well, it's reporting that it's in my lookup function to find the variable names and function names.
Yeah.
But yeah,
But if the answer is it's because you missed a couple cache lines, a hash table will still have a couple cache line misses.
yeah. Okay.
So instead, the answer is you're at the limits of what the hardware can do, or maybe the answer is you need to shrink all of your IRs so that when you go ask this question, it's more likely it's in cache.
Yeah. I think I gotta measure stuff first so I know my numbers.
Okay.
Yeah.
Fine. All right. I have done drinking my slime goo, but I still have the follow-on issues for the next few hours, so I'm ready to be done here.
All right. See you around.
I'll be so much happier in about 5 hours from now.
Well, sorry to hear you're having a shitty day.
Yes, thank you. Very shitty day. All right.
Good.
Bye.
Bye.